of this package was to graph 3 functions. These are the 3 main functions that we're going to be using for this unit. Then we kind of observed some different things that we can do to those functions. We can make them skinnier, we can make them wider, we can flip them, we can shift them around. So you should have noticed all of those as you were filling out your package yesterday. So this was the first graph. You should have 4, 1, 0, 1, 4 as far as points there. So that's what it should have looked like. The next one is a square root function. The square root function actually doesn't go any further than 0, 0. So if you happen to extend it over there, that shouldn't have happened. So starting at 0, 0 and then curving off to the right, the numbers should have been 0, 1, 2, 3. And then the last function, you might want to pencil this in. The last function actually has asymptotes. So you should maybe be showing those asymptotes with vertical lines like so. Dotted lines, I should say. Vertical and horizontal lines. Sorry, it's not super visible. Maybe we'll go orange. There we go, that's better. So dotted line, and this is an asymptote at the line x equals 0. And this one also has a horizontal asymptote at the line y equals 0. And one important thing that you want to just check over in your own sketch of this function is that this function shouldn't actually be crossing over the asymptotes at all or touching them. So you should notice that the function actually curves around those asymptotes but never crosses over it and never touches them. Okay, the numbers were -0.5, -1, -2, 2, 1, and 1/2. Okay, so you can pencil that in if you need to. Okay, the next part of this is the transformations. So hopefully you guys took a second to read this, but this is kind of the general skeleton equation. We're going to talk more about this today. We have A changes, we have K changes, we have D changes, and C changes. A and C are changes to the Y, meaning they're always vertical changes, changes to the Y coordinates of whatever original function we're working with. And K and D are changes to the X coordinates of the original function. The 3 main functions that we're going to be performing changes to are the 3 that we just graphed at the beginning of this package. Okay, and so they are horizontal changes. Okay, so we took some time to kind of explore what happens in these certain scenarios. So when A was greater than 1, you should have seen that the graph, this is the new sketch right here, the graph looks skinnier than the original graph. So you should have chosen A for that one. Whereas if A was a value between 0 and 1, the graph looked wider. So this was a vertical compression. Okay, so A and B. Moving forward. If the C value was positive, you should have noticed that your graph was shifted up. So you should have a sketch kind of like this. And if C was negative, you should have noticed that your graph was shifted down. So you should have a sketch like this. Avery, do you have your package? Okay. The K value, this is a horizontal change, okay? So if the K value was greater than 1, you should have noticed that your graph looked like it was skinnier, which is actually a horizontal compression. So when we think vertical, if I compress vertically, the graph is going to kind of go like this, right? But if I compress horizontally, the graph will look skinnier. So K and A are kind of opposites, right? And then K, if K was between 0 and 1, you should have noticed that your graph was wider, which is a stretch, okay? So when K is between 0 and 1, this is a horizontal stretch. So think about taking your graph and stretching it like this. Nicole?
Is there any difference besides the A and K values between vertical stretch and horizontal?
So the vertical stretch are changes to Y coordinates, whereas the horizontal compression is changes to X coordinates. So they change different coordinates from the original function that we're working with. So it will be, so if I stretch by 2 vertically and I compress or horizontally compress by 1/2 or whatever, it will have actually different points. So it's 2 different, yeah. It looks similar, but it's different. Okay, D value. If the D value is negative, you will see that your graph shifts left. Okay, whereas if your D value is positive, you should see that your graph shifts right. Do you guys have these changes on your sheets? No? Can you alter that for me? So if you guys have them opposite, then that's fine. But this one, I'm not sure if you guys have, can I see your? Oh, yours is opposite. Okay, perfect. Okay, so you guys are good then. Okay. All right. What happens when the A value is negative? This is a vertical flip, so it gets flipped over the x-axis. Bonnie? Can you just wait till we finish taking this up? Okay, and then when the K value is negative, this is a horizontal reflection, so you should get it mirrored over the y-axis. Okay, the impact on the +3, this is a D value. And you'll notice that the D value looks like +3 in here, but it's actually -3 when we state the actual D value. So it looks opposite in the equation to what it actually appears. This is a shift 3 units to the left. So you should have something over here, and this should be the value -3. Okay, so the D value looks opposite when it's in the equation. It looks like +3, but the D value is actually -3. Okay, and then when the C value is positive, you'll notice that it's actually outside the root. Okay, so I can actually tell the difference between D and C here because the D value is under the root, whereas the C value is outside the root here. Okay, the C value is exactly as it looks. It's +3. It looks like +3 in the equation. And what this does to our graph is it shifts it up 3 units. So you should have this point right here at 3. Okay, so this is what I was just talking about. So if the +3 is under the square root, it's a horizontal change, whereas if it's outside the square root, it's a vertical change. Okay, so inside, horizontal change with the x, outside of whatever operation is happening, that's a vertical or y change. Okay, so if we have something like this, a D value of 3, your prediction should have been that it would shift the graph right 3 units. Okay, and then if we have a D value of -3, it should shift the graph left 3 units. But it looks opposite in the equation as to what it actually is. Okay, so this looks like -3, but that's actually a D value of +3. Shift right 3 units. Okay, and then these are our predictions. So the +3 will look like it's shifted left, and the -3 will look like it's shifted right 3 units. Okay, so it's opposite of what it appears. Yep. It will be. Yep.
Is this for the C value?
This is the D value. Okay, the C value won't be included under the root. So the C value, if it's -3, notice that it's not being covered by the root. So it's outside, like so. The C value is exactly as it looks. If it looks like -3, the C value is -3, that shifts the graph down 3 units. Whereas for our other one here, it's a +3, it's outside the root. That's a C value of 3, and it should have shifted our graph up 3 units. Okay, so here are 2 examples of what the graph should look like. This one's up 3, whereas this one should be down 3. Okay, so the minus is the down one, and then the plus should have been the shifted up version. So the C value is exactly as it looks. Okay, next part of this, A value versus K value. So the K value will be under the root or inside the square or whatever we're working with. This was a horizontal flip, or you could have called it a reflection. That works as well. Whereas when you have the negative outside, this is an A value, and that should have been a vertical flip or reflection. Okay, so this one's the horizontal one. That one's the first one, and this one is the vertical one. It's a flip vertically, whereas this one's the flip horizontally. Okay, so check your work with that one. Okay, and then last couple of things here. So if I see something inside with the squared, that should tell me that that thing is a D value. So D and K will always kind of be inside the operation of that main function, whereas A and C will be kind of on the outsides. So this one is inside the squared, right? Like it's inside the brackets. That tells me that it's a D value, and remember D is always opposite of what it looks. So this one should have been a shift left 2 units. This one is a C value. What do you notice about this versus the D value? Like how can we tell the difference between those two? How do we know the first one's D and the second one is C? Kylie's? Yeah, so it's not part of the squared part of that, right? So I know that this is a C because it's not inside the brackets with this, like in the squared part. Okay, when C is positive, that should have been a shift up 2 units. Okay, so those are the sample graphs. This is your shift left, and this is your shift up 2 units. Okay, almost there. So the D value is always what we call inside the main parent function. So example, this one's inside, and this one is also inside. So it's inside with the squared, or it's inside of the square root, whereas the C value is kind of like outside. So it will be not in with the squared part or not under the root. Those are C values. Okay, so a couple of these that we just want to identify, whether they're D value or C value or neither. This one is inside the squared, so that tells me that this should be a D value. This one is outside the root, so that tells me that this should be a C value. This one is not an addition or a subtraction. This one's actually either an A or a K, so that one should have been a neither. This one's a D value, it's inside the root. This one, again, it's not an addition or a subtraction, so that one's a neither. And this one's outside the squared, so that one is a C value shift. Okay, so there are a bunch of different types of transformations. We have stretches, compressions, what we call reflections, or you can call them flips. And we have shifts, or another word for those is called translations. And any of these could be vertical or they could be horizontal. So take a second and write those down if you need to. Okay, and then this last page is the especially important page because this is kind of your summary of everything that you've learned through the package. So you're just going to want to make sure that you have circled the correct things here and filled in the blanks correctly. So when A was greater than 1, it was a vertical. The A value is a vertical change, and it was a stretch, so the graph got skinnier. So you should have vertical and you should have stretch. Okay, when A was between 0 and 1, A is still vertical. So you'll notice that for all of these A ones, I have vertical, vertical, vertical. That was a compression between 0 and 1, so something like a half, for instance. Okay, and then when A is negative, that is a vertical reflection or flip. Liam, can you grab the back door there? Thanks. Okay, so vertical stretch, vertical compression, and then vertical reflection or flip. Okay, the K value. What do you notice about all of the K value, the first space for the K value? They're all horizontal. The K value is a horizontal change. That's the very first thing after you graph those 3 functions that is told to you. So all horizontal. When K is greater than 1, it's a horizontal compression. When K is between 0 and 1, like a half or something like that, it's a horizontal stretch. And then when K is negative, it's a horizontal reflection. Okay, so please make sure you have that filled out. This is a really great summary page of what we're going to move forward with in this unit. Okay, last ones. When D is negative, it appears positive in the equation. Okay, D is always opposite of what it appears, and it causes a left shift. Okay, so when D is negative, it's going to look like positive in the equation, looks opposite how it appears, and that causes a left shift. When D is positive, it appears negative in the equation, but it causes a right shift. Okay, and again, D is a horizontal translation. That's why it's left and right versus up and down. Okay, and then the last one, when C is positive, it will look positive in the equation and it will cause an upward shift. And when C is negative, it will look negative in the equation and it causes a downward shift. Okay, and the C is a vertical change. That's why it's up and down. Okay, so the last part was to identify A, K, D, and C in the equation. If you don't see A or K, they were just 1. If you didn't see a D or a C, they were zeros. So A should have been 2, 3, positive 1. Remember that the D value always looks opposite of what it is in the equation. And C is 4. Okay, this guy, you only really see a C and a D here. So D was negative 2, remembering that it's opposite of what it looks. C is negative 7, and then as the instruction said, if you don't see A and K, they're just 1. Okay, this one had an A value of 4, a K value of 0.5, and a C value of negative 1. Since we don't see the D value inside the brackets with the X, it was 0. Okay, here we don't see an A value, so it's 1. The K value is negative 4. The D value is negative 5. Remember to switch the sign there. And we don't see a C value, so the C value is 0. Okay? Anything that I haven't highlighted above doesn't change the parent function at all. So those are actually, remember how we had the defaults for the slider? Those are the original function unchanged. So the things that I've highlighted here are things that are actually impacting the graph of the original function. They're actually changing it around. Okay, any questions on this page here? We're all okay with this stuff?
Anything highlighted
Does change. So anything not highlighted doesn't change the parent function. But if it is highlighted, it will change the parent function. Okay, so I will post this on Edsby. If you need to go back and look at anything, you can. So we're going to kind of do a summary in today's lesson of the order of transformations, and we're just going to make sure that we have them all down as far as A, C, D, and K. And then we're going to actually perform some transformations. Okay, so there is a specific order that transformations needs to happen in, okay? So this order is important because if we do them out of order, we'll actually get the wrong final graph. So actually, if you work your way left to right in the equation, it takes care of order of transformations for you. So you're going to do A, and then you're going to do K, and then you're going to do D, and then you're going to do C. Basically, the rule is that stretches, compressions, and flips have to happen first, and then shifts or translations is another word for that, have to happen last. So if I do K first before A, that's fine. But I want to make sure D and C are done at the end. They're shifts. Part of the reason that we do that is because, do you guys notice that A is being multiplied here and K is being multiplied? I want to do multiplications first, whereas D and C are being added and subtracted. So I want to do multiplications before I do additions and subtractions. That's bedmass, right? So that's why we have a specific order to transformations. So we do all stretches, compressions, and reflections or flips, whatever you want to call it. They must be done first, and then the shifts or translations are last. Okay, A value. So your A value summary, these are changes to the y coordinates. They are vertical changes. When A was greater than 1, this is what we would say, so kind of how we express this in words, is we say this is a vertical stretch, and then we usually indicate the stretch factor. So if A is 2, for instance, we would say vertical stretch by a factor of 2, which means that we're taking all the y's and we're multiplying them by 2. So we would say by a factor of whatever the A value is of A. Okay, and the operation that we're doing is we're multiplying our y coordinates by this value. Okay, when a is between 0 and 1, can someone give me an example of something between 0 and 1? Between 0 and 1? Bonnie? Half. Did you say a half or did you say 5? Oh, sorry, I thought you said 5. I was like, not quite between 0 and 1. Okay, 0.5, yes, or a half. This would be, so example, this could be when a is a half. This is a vertical compression, and then we would usually say by a factor of whatever that value is. So in this case, in our example, it would be by a factor of a half. But I'm just going to say of a, and you will fill in the blank. Okay, and again, we're going to multiply the y's by this number, or if it's like 1 over 2, that's the same thing as dividing the y's by 2, right? So multiply y's by a, or you can just divide by the reciprocal, right? So you divide by 2, essentially. But we're always multiplying our y's by that a value. Okay, and then if a is negative, if a is less than 0, or in other words, negative, this is a vertical reflection. And we don't have to say by a factor of anything, it's just a vertical flip. We flip it vertically. Okay, it is possible, thank you. It is possible that we could potentially have a compression and also a flip, right? So I can compress it vertically, and then I can flip that around. So that would mean I would have something like negative half, right? So if the negative part is the flip part, the half part is the compression part. Okay, C. This is the other y coordinate change. This one's pretty easy. If C is positive, it shifts our graph or translates our graph up that many units. If C is negative, it will shift our graph down that many units. So shifts down, we'll say C units. Pretty straightforward. Positive up, negative down. The important thing is, again, to remember that these are vertical changes. So they change the y coordinates of whatever function we're working with. Okay, and then the horizontal changes, you'll find them inside the function, like inside the squared or the square root or whatever. They are k and d. So k is a little bit, it's essentially almost the exact opposite of a. So when k is greater than 1, we would say this actually produces a horizontal compression. And we actually use the inverse of k. So we actually use the reciprocal. Maybe I shouldn't say inverse, but reciprocal of k. So when we say by a factor of, we actually say by a factor of 1 over k. So we actually flip the k value. So if the k value is 3, we say horizontal compression by a factor of 1 over 3. Okay, so essentially what we're doing is multiply the x's by the reciprocal of k. Okay, so we have to remember that k and d, there's always something that we need to do to these before we do our calculations of our points. Okay, and then if k is between 0 and 1, like a half or 0.5, this is going to be a horizontal stretch by a factor of the reciprocal. So if it's a half, the reciprocal is 2. Okay, and we are always multiplying the x's by that reciprocal. Okay, and then if k is negative or less than 0, that is a horizontal reflection. Okay, and then d, so remember d looks opposite in the equation as it actually is. So if d is positive, it will look negative in the equation. Bonnie, you can go now if you need to. this will shift right d units. Okay, and then if it's negative, it will look positive in the equation. And it will shift left d units. Okay, so these are kind of going to be my skeleton the skeleton statements that I'm going to use if I have to write transformations in words ever. If my d is 3, then I'm going to say shift right 3 units. Or translate right 3 units, if you want to use translate. Okay, and remember K and D, they're changes to the x coordinates, and they are horizontal changes. Okay. The 3 basic graphs, I'm not gonna graph these again because they're on your package. But it's good for us to make sure that we have these. So if they're not in your package, you're gonna want to make sure you go back and you fill these guys out. Maybe I'll just do them really quickly, but I'm going to do this fast because I think you guys most of you already have this. So this is a quadratic. Okay, these key points are the key points that you are going to perform these transformations on that we're talking about. So the main key points that you should have are -2, 4, -1, 1. They're in your table of values on your thing. And then 1, 1, and 2, 4. Okay, and this is what your graph should look like so. Okay, if you have them in your package, you can redraw it quickly, or you can just say refer to package. Yep.
Every time we draw it, do we have to write f of x?
So we're going to do transformations, so it might be helpful for you to label the original function and then the transformed one once you do that. But if it's just one graph and the function is like right above it, I don't think it's necessary that you label it f of x. Good? Okay, next one. This is a square root function. And the key points, I actually specifically, strategically choose some x coordinates for this. Did you guys notice I chose 0, 1, 4, and 9? Isn't that kind of weird? Why didn't I choose something just like 0, 1, 2, 3? Katie?
Because these are all square root.
Yeah, we can actually square root them and get whole numbers. So yeah, you can choose 0 to 5 if you want, 0, 1, 2, 3, 4, 5. But then you're going to get some decimal values, and we kind of want to avoid that. I also purposefully didn't choose any negative x values. Why didn't I choose negative x values? Yeah, I can square root negatives. So this function is actually undefined for the x's that are negative. So I get my y's by square rooting them, right? So 0 square rooted is 0, 1 square rooted is 1, 4 square rooted is 2, and 9 square rooted is 3. So this is what your function should look like. Again, we're doing this fast because we should already have these graphs. Okay, it kind of looks like half of a parabola on its side. Okay, and then the last one is called a rational function, like fraction. And the key points of this guy were -2, -1, -half, half, 1, 2. And then you guys sub them in to get your y coordinates. Why didn't I choose 0 as one of my x coordinates here? I purposefully skipped over that. Why can't I choose 0? Bonnie? Yeah, I can't sub in 0 here because then I'll have 1 over 0. We know that's undefined. So we don't ever choose 0 as our key point for this one. But then when we start subbing these in, we get -half, -1. This one gives us -2, which is kind of why we included that half, because it ends up flipping and becoming -2. So that's a good point to have. This one becomes 2, 1, and half. This one also has a vertical asymptote along the line x equals 0 and a horizontal asymptote along the line y equals 0. Okay, so we are actually going to always show our asymptotes with dotted lines because they will actually get shifted with any d and c value shifts. So we want to make sure we draw them in. We also want to draw them in just so we know where our graph is going to avoid. Okay, so we have y equals 0, and then if we graph our 3 points here, get these on the left, and then we get something similar on the right. We get something like this. Okay, so notice again that I'm not touching my asymptotes and I'm not crossing over my asymptotes. This isn't two different functions, this is all one function, it just has two pieces. Okay? Any questions for the main functions? So these are the three main functions that we're basically going to work with for this chapter. So it's important that you make sure that you keep either your package with those key points or this lesson with the key points because you'll probably be referring back to them. Okay? Okay, we're going to start some transformation stuff to see if we can identify some of our transformations here. Okay? Remember that this is the main function. So our skeleton function from our package was this. Okay? This part is not a transformation. It just represents the parent function f at x. Okay? So our transformations are a, k, d, and c. So we want to make sure that we can identify those in a function if necessary. Okay, so this value right here, this is a -1, it's being multiplied. Is this an A, K, D, or C? This is an A. So A here is actually just -1. So because it's still 1, it's not stretched or compressed at all, but this is a vertical reflection. Okay, so the only thing that happens here, there's only one transformation, it's a vertical reflection. So what we will do is we would take our y's and multiply them by -1. So we would do like -1 times all the y coordinates. Okay, what I'm talking about as far as the math of this will become a little bit more clear as we actually do some of the transformations. Okay, what do I have in number 2 here? I have two multiples out of A, K, D, C. Bonnie?
Sorry, I was on 3. Can you do A equals 2 stretch?
So the first transformation that we would do, keep in mind that I'm doing these in order. I'm working my way left to right in the equation. This is a vertical stretch by a factor of 2. Sometimes for by a factor of, we use BAFO, by a factor of, just so we don't have to write the whole thing. So, okay, and what we would do is we would take our y's and we'd multiply them by 2. What is the 1/3? This is a k value, good. So when I state the k value, it will stay as it is. But when I go to write the actual transformation, this is going to be a horizontal stretch by the reciprocal. Okay, so remember A and K are kind of like opposites. So this is a horizontal stretch by a factor of 3. What I would do is I would take my y's, or my x's, and I would multiply them by 3. So actually use this reciprocal value. Okay, going on to the next. What do I have out of A, K, D, C? Essay? Close. I have an A and a C, but not a K. Katie? This is a D. Why is it a D and not a K? Yeah, and it's also an addition, right? So K's are multiplications inside the bracket with the X. So we have an A, so that's our first transformation, A equals 3. This is a vertical stretch by a factor of 3. And what we would do is we would take our Y's and multiply them by 3. The second transformation, when I state the D value, I always have to remember that it looks opposite in here of what it actually is. D is actually negative 2 here. This is a shift left 2 units. Okay, so D is always opposite of how it looks. So I would actually take my X's and I would subtract 2 from them. Okay, and then the third transformation, again, remember I'm working my way left to right here so that I do the transformations in the proper order. It is a C value of negative 1, which is a shift down 1 unit. Okay, so with my earlier transformation to the Y, I now have 3Y, and then I would subtract 1. Okay, so the 3Y, of course, is the vertical stretch, and then we minus 1, and it shifts the whole thing down 1 unit. Any questions on this one? Okay, let's try another one. What do we have here out of AKDC? 1/4 is A. Bonnie, what else? D? Isabella?
Wait, is it K equals, yeah,
Okay.
like, if it's, like, a K minus 1, that's D, because it's a negative and it's in the bracket, so K would only be a multiple.
Right, so that's why this is K, right?
Okay.
So, and then D is the one that we do opposite, so D is actually positive 1 here. Okay, so this one is actually a vertical compression. Okay, it's between 0 and 1 for A by a factor of 1/4. Okay, so what we're doing here mathematically is we're taking our Y's and we're multiplying them by 1/4, or we can just say Y divided by 4. That's the same thing, right? So same idea, multiply by 1/4 or divide by 4, same idea. Okay, when K is at 2, we want to think of the reciprocal, so half. So this is a horizontal compression by 1/2. Okay, and what we do is we take our X's and we multiply them by 1/2, or same idea would be to take the X's and divide by 2. Joey?
Where's it the half from?
So we always, for K, we're always using the reciprocal. So here K was 1/3, but we stretch by 3. So here K is a 2, so I have to do the reciprocal, which is 1/2. Yep, and then D is opposite of how it looks in the equation, so it's actually positive, so this is a shift right 3 units. Or 1 unit, sorry. And what this will result in is my earlier horizontal compression, and then I will add 1 to it. So that's what I'll do to my X's. Any questions? You okay there? Okay. One more. This one has everything. Okay? This one has an A, it has a K, it has a D, and a C. I'm going to make sure I work my way left to right here so that I do the transformations in the proper order. All shifts and must be done last. Stretches and compressions and flips are done first. So A here is -5. This is actually 2 different transformations. The negative part of this is a vertical reflection. The 5 part of this is a vertical stretch by a factor of 5. Okay, together, this tells me to multiply my y's by -5. The negative will flip it, the 5 will stretch it. Joey?
What is BAF stand for again?
By a factor of.
So we write of again.
Oh, sorry, that's my fault. No of, just by a factor of 5. Okay, second one, the k value is -1/4. This is, again, two transformations. The first one is a horizontal reflection, or flip. The second part of this, I want you to think reciprocal. So what's the reciprocal of 1/4? 4. So this will be a horizontal stretch by a factor of 4. Okay, notice that I'm not saying -4 because the negative part of this is the reflection part. The numerical part of this is the stretch or compression or whatever. So what I would do to my x's here is I would multiply them by -4. The negative for the reflection and the 4, the reciprocal of k. Okay, can somebody tell me what my d should be equal to here? Kylie's? -2, flip the sign, very good. So this must be a shift left 2 units. So with the earlier transformation, I would have -4x minus 2. And last one, the c is +7, shift up 7 units. And with the earlier change to my y coordinate, it will be -5 plus 7. Okay, we're gonna hold it there. I want to give you guys at least like 10 minutes or so to get these straight in your minds. Okay, I know that it's a bit, so feel free to look back at your notes. That last page, or the last like couple pages of your package, that's really where you have the whole summary of everything, but we obviously redid the summary on the front of this lesson. So please be referring back to that as you're looking. Eventually you'll get the hang of it, right, Lauren? We do this like all through like grade 11 and 12. So you will get the hang of it.